Hello everyone, my name is Shreya Kavle, accompanied by my colleague Nile Kavde, and together we represent B1 Group 1 from the Electronics and Telecommunication Engineering Department. It is our privilege to stand before you today to deliver a presentation on the topic Analog versus Digital Multimeters. Throughout our discourse, we aim to provide a comprehensive examination of both analog and digital multimeters. Our presentation will encompass an in-depth analysis of their working principles, block diagrams, interfacing methodologies, features, and diverse applications. Without further ado, let us commence this exploration into the realms of analog and digital multimeters, unraveling the intricacies that define their functionalities and uncovering the breadth of their practical applications. Starting off with analog multimeter. An analog multimeter utilizes the movement of a pointer on a calibrated scale to measure electrical quantities. It relies on the physical movement of a coil in response to the electrical current being measured. This is what an analog multimeter looks like. Coming to its interfacing and features. Analog multimeters have a scale where the user reads the measurement value based on the position of the pointer. They generally respond to changes in the measured quantity more slowly compared to digital multimeters. Analog meters may require zero adjustment to compensate for any initial misalignment of the pointer. Advantages of using analog multimeters. Analog meters provide a continuous scale, making it easier to observe trends and changes in the measured quantity. Analog multimeters are often less expensive than their digital counterparts. Disadvantages. Analog meters might not offer the same level of precision as digital ones. Reading the scale requires the user to be directly in line with the pointer, introducing the possibility of parallax error. Here is a block diagram of analog multimeter. Starting from the bottom, we have a common socket and there are two more sockets out of which we have to select one depending on whether we want to measure current, voltage or resistance. It also comprises of 4 other resistances, 1 shunt and 3 multiplier ones, along with a meter display at the top and a rotatory switch. Now, coming to the digital multimeter. A digital multimeter converts analog signals to digital form using an analog to digital converter (ADC). The result is displayed on a digital screen, providing a numerical readout. This is what a digital multimeter looks like. Coming to its interfacing and features. Measurements are directly displayed as numerical values on an LCD or LED screen. Digital multimeters generally provide higher accuracy and precision in readings. Many digital multimeters have auto-ranging capabilities, automatically selecting the appropriate measurement range. Advantages of using a digital multimeter. Digital multimeters are known for their high precision and accuracy. The digital display eliminates the potential for parallax errors associated with analog scales. Some digital multimeters offer additional features such as data logging, frequency measurement, and capacitance measurement as well. Disadvantages could be digital multimeters can be more expensive than analog ones. In some cases, digital meters might have a slightly slower response time to rapidly changing measurements. Here is a block diagram of digital multimeter. We see it comprises of an input probe connected to the rotatory switch, a bunch of converters in the middle, all going to the most important part, the ADC, the analog to digital converter, right reaching the digital display at the end. We can infer that this ADC part converter was not present in the analog meter. In summary, the choice between analog and digital multimeters depends on factors like cost, precision requirements, and personal preference. Analog meters offer a traditional continuous scale reading, while digital meters provide accurate numerical results and additional features. Digital multimeters are increasingly popular due to their precision and ease of use, but analog meters still find applications in certain scenarios. So in today's video, we'll be showing you how to measure resistance, measure voltage across the resistor, and current across the resistors in series combination using both analog and digital meters.